All right, so now we're dealing with conditional probability. So the probability of event B, assuming that event A has already occurred, is called conditional probability of B given A. Now this is denoted as the probability of B given that A has already occurred. So that's how that's read. Now it's helpful to think of the conditional probability of B given A as the probability that event B occurs if the sample space is restricted to the outcomes associated with event A. Okay, so that's kind of another way to think about it. So if A's already occurred, then we have to base a probability of B on what happened with A. Now, how does that work? All right, well, here we have a letter is randomly selected from the letters of the English alphabet. Find the probability of selecting a letter that precedes H, given that the outcome is a vowel. Now, don't include the letter Y among your vowels. So that's kind of a key thing. So some people include Y, some people don't. In this case, we're not including Y. So our event, we want the probability of, it's going to be a B given A. Well, what is A? Well, A is going to be that we have a vowel. So our sample space in this case is going to be all the vowels, A, E, I, O, and U. So that is going to be our sample space. That's going to be what happens with A, because that's what we're given as A. The outcome is a vowel. So those are the outcomes. Now, find the probability of selecting a letter that precedes H, so before H. So if we don't remember alphabet, A, B, C, D, E, F, G, H. So we want basically a vowel that precedes H, or basically we want a letter that precedes H that's given one of these. Well, guess what? There's an E, it's one of these, and there's also an A, which is one of these. So what we have is the probability of a letter preceding H given it's a vowel is going to be what? Well, there's two possibilities out of how many? One, two, three, four, five. So that would be our actual probability for that one. Okay. So let's do another one. If you're dealt one card from a 52 card deck, find the probability of getting a black card given the card you were dealt is a spade. And then the second one says find the probability of getting a spade given the card you were dealt is a black card. All right, so for the first one, we want the probability it's a black card given that we had a spade. Okay, well, if we're given our sample space is going to be the spades, so all spades. Okay, well, what we're asking for, what is B? B is going to get a black card. Well, all spades are black, so there's 13 of these, and so there's going to be 13 possible black cards. And so basically what we end up with is 13 over 13 because there's 13 possible black cards out of 13 spades. And so if we reduce that, the probability of that's going to be basically one. So the probability is one that you're going to get a black card if you have a spade. Okay. Now, B, find the probability of getting a spade given that you were dealt a black card. So this is kind of the other way. So a spade given that it was black. All right. Well, in this case, our sample space is going to be all the black cards. Well, all the black cards are the spades and the clubs. So how many are there? Well, there's 13 here and there's 13 here. So there's 26 in our sample space. So that's going to be our denominator. And we want the spades is what we're going to pull out of. So we're going to pull out how many? We're going to pull out 13. So that's going to give us 13 out of 26. That probability is going to be 1/2 after we've reduced it. Okay. So again, we're thinking about our sample space is the second part here, either the spade or it's a black card, which is the spades and clubs. And then our numerator is going to be what the first part is. It's a black card. Well, out of those sample space, which ones are black? Well, all 13 of them are black, so it's 13 over 13. Now here, out of all those 26, how many of them are spades? Well, there's 13, so it's 13 out of the 26. All right, so let's stop here and we'll come back for some more.